Hi everyone, let's solve this problem. Longest increasing subsequence. Given an integer array nums, return the length of the longest strictly increasing subsequence. So we are given these numbers. Let's say for example, in this case we have 2, 5, 7, 18 as the longest subsequence, or we can take 2, 3, 7, 18, or we can take 2, 3, 7, 1, 0, 1, or 2, 5, 7 and 1, 0, 1. So if you see here in this case, if I take this particular sequence, subsequence is nothing but we can skip a few elements in between, so that is called as subsequence. So they are asking us to find the length of the longest increasing subsequence. Increasing is nothing but the previous element should be lesser than the current element. That is all they are telling, because it's a strictly increasing, they cannot be equal, and we have to find the length of it. The length is 4 here. So let's solve this using DP problem. Let's see how we can solve that. Let's say for example, like if you are at, consider that this is at ith index, and if you are at the ith index, consider this as the subsequence starting at I. So that is how we define it. And then if you consider all the elements can be considered as longest increasing subsequence if we take the element individually. So that is the reason all of them are filled with 1. Now we can start from here. When I start from here, 101, there is one possibility 18, but 101 is greater than 18, so we are not going to do anything about it. We are just going to move forward, and at this point of time, 7 has two elements, 101 and 18. Both of them are greater than 7, so already I have LIS of I, LIS of j. I have to take max of this at any given point of time, and this is only valid if nums of I is less than nums of j. So now when I am at this particular position 7, both of them are validating this condition. Both the cases are true for this case. Now LIS of I is 1 already, and I have to find 1 plus 1 because this value is 1. So now it is already 2. Now again the same condition succeeds here. Now LIS value is 2. 1 plus 1 is 2 already. 1 plus 1 is again 2 here. 2 comma 2 max is 2. We don't really have to update anything. So then after I am done with this 7 element, I will again move to the previous element 3. In case of 3, I can go to 7, 101 and 18, and all of them are greater than 3. So we have 2 value, 1 value and 1 value. So basically LIS of I is 1, LIS of I is 1, and 1 plus 2, it is nothing but 3. So we are going to update our LIS of index 4 with 3, and we are not, even though if we iterate over this 3 comma 2, 3 will be maximum, so it's already there. Same thing here, 3 comma 2, 3 will be the maximum, so 3 will be updated here. Now if you see here, just to explain, 3, 7, 18 is the longest increasing subsequence here, or 3, 7, 101 can be longest increasing subsequence, but we are just worried about the length, so we are just maintaining the length here. Now again I can go to 5. 5 has 3, 7, 101 and 18. So we have 3, 2, 1 and 1, but this case is not valid because 5 is greater than 3. So we are going to remove this case, and among all of this maximum value is 2, so it will be current value is 1, LIS of I is 1, and 1 plus 2 it's 3. So maximum of 1 comma 3 is 3. So we are going to update it, and we can ignore the rest of the elements. And now let's go to the previous element again, and in this case we have 2 after 2 we have 5, 3, 7, 101 and 18. All of them are greater than 2, so we can consider all the possibilities here, and we will just take the counts. So we already have 1 and 1 plus 3, it is nothing but 4. So 4 is updated again, this value is again going to be 4, and all of these are going to be lesser than 4, so we will not update our LIS. Once this is done, again we will be moving to the previous element, and at this element we are at 9, 2, 5, 3, 7, 101 and 18. If you see 2 is lesser than 9, so we will ignore this path. 5 is lesser than 9, we'll ignore. 3 is also lesser, ignore. 7 is also lesser, ignore. Now we just have 101 which has a count of 1 and 18 which has a count of 1. So LIS of I is 1, and we are going to check LIS of 1 plus LIS of j is nothing but 1. 1 plus 2 is 2, 1 comma 2 max is 2, so we are going to update it, and again it is going to happen same with 18 as well. So we already have a better answer, so we don't need to update if it is equal. So then we have 10. In case of 10 as well, we have 9, 2, 5, all the elements after that will be there, 101 and 18. But if you see, these elements are not valid because they are lesser than 10, so we can ignore all these elements, and now we are just left with 18 and 101, and 101 has 1, 18 has 1, so it will be 1 comma 1 plus 1 which is 2, so we will update it. And after we have finished our array, we are going to check the max value in the LIS, and it is nothing but 4, so our answer is 4. Now let's try to write the code for the same. We are just having a variable to get the length of the nums array, and we are going to iterate from n minus 2 because 1 second greater than or equal to 0, say minus. So we are any which ways for this case it is going to be 1 as the answer. We don't have to do anything, and we have to start here because there is a possibility of getting the answer of 2. Let's say for example, instead of 101, if it is 11, 1 plus 1 will be answer will be 2. So we can ignore this and we can start from n minus 2 because the answer here any which ways is going to be 1. And then we are going to iterate using, okay, it should be I, and our j is starting from I plus 1 and j is less than n, j plus plus, and we are going to only update our LIS. Okay, we also have to define our LIS or LIS as an array of length n, and we have to fill all the elements with 1, and we are going to only update LIS of I value when nums of I is less than nums of j. So in this case LIS of I will be Math.max of, if we already found the answer which is greater, we don't really have to update, we will just take the same value, else we are going to update 1 plus LIS of j. and at the end we are going to get the answer as 1. We have to find the max value, so we are going to iterate over the LIS array. Answer is equals to answer comma LIS of I. Then we will return the answer. Now let's try to run this. Submit it. Okay, it's successful. Now let's try to understand the time complexity of the solution. It is nothing but big of n square, because we are iterating over all the elements and then there is an inner loop which is going through all the respective elements. Let's say when we are here, we are go through all the elements, rest of the elements, which is nothing but n square. And then space complexity is big of n to store the LIS values. I hope the solution is clear. Thank you.